Okay, now see today's our topic is rules for filling of orbitals in an atom. We know electrons are filled in different orbitals. Okay, electrons fill in different orbitals, and every atom contains a different number of electrons. For example, the atoms of hydrogen element have only one electron. If you take sodium, one atom of sodium has 7 electrons. One atom of calcium has 20 electrons. Here, how the 20 electrons are distributed in calcium? How the 7 electrons are arranged? And what is the position of this 1 electron in hydrogen? So, here already we know that one atom of an element contains a fixed number of electrons. But how they are present? So what is the distribution of that electrons in the atom? అంటే ఒక ఎలిమెంట్ కి సంబంధించిన atom లో సో ఒక ఫిక్స్డ్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఉంటాయని తెలుసు. బట్ ఆ ఎలక్ట్రాన్స్ ఎట్లా డిస్ట్రిబ్యూట్ అయ్యి ఉంటాయి? సో అలా ఒకే దగ్గర గ్యాదర్ అయి ఉంటాయా? సో డిఫరెంట్ లెవెల్స్ కొన్ని ఉంటాయా? సో దట్ ఈస్ కాల్డ్ ఫిల్లింగ్ ఆఫ్ ఆర్బిటాల్స్ ఇన్ అన్ atom. Filling of orbitals means filling of orbitals by electrons in different orbitals. So there is some specific rules are there to fill the orbitals with electrons in an atom. That is mainly filling of orbitals takes place based on Afgo Principle. The main important principle for filling of orbitals with electrons in an atom is Aufbau Principle. So it is other thing that Aufbau Principle again it depends on some other principles. Okay. So it is based on Paulis principle, that is known as Paulis exclusion principle. And the other thing is also known as Hund's rule. Hund's rule. Okay. So these are the main 3 laws takes place in filling of orbitals with electrons in an atom. First we see about the main rule, that is Afgo Principle. So what is Afgo Principle means? In an atom, if more than 1 electrons are present, then only the problem arises. That's why more than 1 electrons, that is known as in multi-electron system. In a more than 1 electron system, how the electrons are arranged. So, Afgo Principle we can write like at first, electrons are filled. At first, electrons are filled in lower energy orbitals. After completion of lower energy orbitals only, higher energy orbitals filled. Means if there is a possibility of 2 or more orbitals, only 1 orbital there is no problem. If more than 1 orbitals are present, at first electrons are filled in lower energy orbitals. After completion of the lower energy orbitals only, higher energy orbitals will be filled. So means more than one orbitals ఉంటాయి. ఫస్ట్ లోయర్ ఎనర్జీ ఆర్బిటాల్స్ ఎలక్ట్రాన్తో ఫిల్ అయిపోయి మొత్తం కంప్లీట్ ఫిల్ అయిపోయిన తర్వాత సో దానికంటే హైయర్ ఎనర్జీ ఆర్బిటాల్లోకి ఎలక్ట్రాన్స్ ఫిల్ అవ్వడం స్టార్ట్ అవుతాయి. ఓకే, దిస్ ఫర్ ఎగ్జాంపుల్ 1s 2s. Okay, these are two separate orbitals. First generally 1s is lower energy than 2s. So at first electrons fills in 1s. In one orbital, how many electrons filling takes place? The maximum number of electrons in an orbital is only 2 electrons. So 2 complete అయిన తర్వాత ఈ 2s లోకి వెళ్తాయి. మళ్ళీ 2s fill up అయిపోయిన తర్వాత నెక్స్ట్ లెవెల్ లోకి వెళ్తాయి. Okay, this is perfect right now. At first electron filled in lower energy orbitals. After completion of that lower energy orbitals only, higher energy orbitals are filled. Okay, so it is the main statement. But here important is how to know. So here important is how to know higher orbital, higher energy orbital and lower energy orbitals. So మనకి ఉన్న orbitals లో ఏది lower energy, ఏది higher energy find out చేయడం, that is important. So for this we follow a formula given by two scientists named Bohr-Bury, which is known as Bohr-Bury rule. Bohr-Bury rule. What is the importance of this Bohr-Bury rule? It is useful to know the order of energy of different orbitals. It is useful to know the order of energy of different orbitals with the help of a rule that is known as n plus L rule. That is known as n plus L rule. Means for given orbital we need to calculate n plus L. Or n plus L value base చేసుకొని given orbitals లో which is higher energy, which is lower energy మనం ఐడెంటిఫై చేయొచ్చు. So how much energy, it is not the criteria here. It is only, it gives the order, means higher energy or lower energy. So అది find out చేయడానికి యూజ్ అవుతుంది. So n plus L rule. So for example, what is the energy of 1s orbital? 1s means n value 1. For s L is equal to 0, we know that it is 1 unit. For example, what is for 2s? 2 plus 0, that is 2. For example, what is for 2p? L value how much for p? This 3. Then what about for 3s? N plus L, that is 3. Okay. 3p, 3 plus 2 is equal, 3 plus 1. 3d, 3 plus 2 is equal to 5. What about 4s? 4 plus 0, that is 4 units. 4p, same for p orbital, L value we know that 1. Then what about 4f? F is also present in the 4th orbit. For what is the L value for f? L equals 3. So we can write many orbitals like this. But we must remember up to this. Okay. So here, by comparison, 1s, 2s, 2p, there is no problem. Okay, with the help of this, we are able to write the energy order. Say which is having the lower energy, one is a very lower energy, less. So one is the highest energy, 2s, it is having 2 units of energy, then it is 3. So for 3 there is a different is for 3, 2 numbers are there. For 2s it is no problem. 1s value 1, 2s value 2, it's an increasing order, no problem. N plus value is higher, energy is higher. Means n plus value directly proportional to energy. N plus value highest unte, that is having more energy. So one is having more energy than 2s. But now the problem becomes at 2p and 3s. 2p n plus value 3 and 3s also is having n plus L value 3. Both are having same number of units. At this time we need to give importance for this nth level. Appudu n value importance ivali. If n plus L is equal, if n plus L value is same, the orbital with a higher principal quantum number with a higher n is have high energy. So n plus value same ఉన్నప్పుడు మనం n value కి ఇంపార్టెన్స్ ఇవ్వాలి. Okay, normally n plus value is different, then there is no problem. So n plus value different గా ఉంటే ప్రాబ్లం లేదు. హైయెస్ట్ ఉన్నది హై ఎనర్జీ, లోయెస్ట్ ఉన్నది లో ఎనర్జీ. సో బట్ n plus value becomes same. n plus value same ఉంటే n value highest ఉన్నది high energy, n value less ఉన్నది low energy. ఇక్కడ n plus value for 2p 3, 3s కూడా 3. So n value the highest, it is high energy, it is low energy. So 2p is greater than, sorry, less than 3s. Then 3s tarvata 4. So for 3p it is 4, 4s also it is 4. So then we need to compare this value, nth value, principal quantum number value, 3, 4. This is the lower value. Then afterwards 5. That is 3d, 4. Again both are in same number of units of n plus L. మళ్ళీ n plus L value సేమ్ ఉన్నట్టు ఏం కంపేర్ చేస్తాం, n value కంపేర్ చేస్తాం. n value less energy, higher is the n, energy is higher, so ఇది low. 3d, so afterwards 4p. So 4p తర్వాత again మిగిలింది 4d. Okay, we can write so any others also. Okay, 4s, 3d, so we can write many. Okay, like this with the help of Bohr-Bury rule, that is also known as n plus L rule, we are able to compare the energies of different orbitals. Here important, these values are not indicates about the exactly energy. Just these values indicates the order of energies. Okay, order of energies used to compare the energies of different orbitals. Okay, ఇప్పుడు మనకి different number of electrons ఉన్నప్పుడు, so the first electron filled in 1s, after completion of 1s filling of 2s, then after completion of this 2p, 3s, 3p, 4s, 4d, like this. Means electron fills in the orbitals in the increasing order of their energies. Okay, this is known as Afgo Principle. Okay, so again it is important to know this order from electron configuration, that is known as distribution of electrons. A distribution of electron, nothing but electron configuration రాసేటప్పుడు we must know this order. So ఈ order మనకు perfect గా idea ఉండాలి. Sometimes so easily we forget this order. So to remember this order, so there is one diagram is given, that is called Moiler diagram. Okay, that is like this. One is 2 here. Just it is only to remember this order. So it is given by the Moiler. So at first, what is that? 1s, then 2s, then 2p 3s, 2p 3s, then 3p 4s, 3p 4s, then 3d 4p, 3d 4p. Then afterwards we will get 5s. So this is the diagram to remember easily. Okay. So after this there is no need. So after completion of 1s, means these are like this. So we need to come like after 1s, 2s. After 2s there is 3s. Completion of 3s, 4s, 3p 4s. After completion of 4s, 3d 4p 5s. Again after completion of 5s, 4d 5p 6s. So this is the simple diagram to remember the order of energy of orbitals, which is known as Moiler diagram. Okay, so this is the main principle in the filling of orbitals with electrons. Okay, now we see other principles involved in writing of electronic configuration. Okay, so that is Paulis exclusion principle. So Paulis exclusion principle. So what is Paulis exclusion principle means? It tells about the electrons present in an orbital. Okay. So according to this, no two electrons in an atom having same set of four quantum numbers. No two electrons in an atom having same set of four quantum numbers. అంటే ఒక atom లో ఉన్న any electron కి, ఒక atom లో ఉన్న any electron, for example if you take sodium, there is 11 electrons are present. So ఆ 11 electrons లో any two electrons కి మనం కంపేర్ చేసిన four quantum numbers values are not at all equal. ఓకే, మినిమం ఏదో ఒక దాంట్లో ఈ 4 క్వాంటమ్ నెంబర్స్ లో ఏదో ఒక క్వాంటమ్ నెంబర్ వాల్యూలో దే ఆర్ డిఫరెంట్. No two electrons in an atom having same set of quantum numbers Very important word, it's mixed. In an atom, okay, ఒక atom సంబంధించిన electrons లో no two electrons are having same set of 4 quantum numbers. Okay, next the another form of it is also known as only 2 electrons are possible in an orbital which are having opposite spin. Only 2 electrons are possible in an orbital. Orbital means just simple, remember it's a box, one box, which are having opposite spin. So it is also treated as Paulis exclusion principle. Okay. Now we see one or two examples related to this Paulis exclusion principle. So already we know how to write the quantum numbers for a given electron in an atom. So take an example. Okay, take sodium. We are writing the filling of electrons. This one. So we are comparing the quantum numbers of this electron and this electron. So 2p6 means so there is 6 electrons are present in 3 orbitals totally. So that can be written as now write this now quantum number values for this electron. What is the nth value principal quantum number? It is present in which shell? It is present in third shell. So n equal 3. It is present in S or S subshell. L equals 0. If L equals 0, we know M is equal 0. S is equal plus of or minus of. Okay, anyone we can take. For example, that is the first electron, just we are taking as a plus of. Means we need to follow any one of the thing. So first electron plus of తీసుకుంటే అన్ని first electron plus of తీసుకోవాలి. లేకపోతే first electron minus of తీసుకుంటే అన్ని box తో అలాగే తీసుకోవాలి. Next, write these electrons. Write this electron. N equal to 2. What is L value? It is present in the P subshell. P subshell value 1. So L equal 1 means there is also minus 1, 0, plus 1. Plus 1. So S is equals, we are talking about the second electron. First electron plus of తీసుకున్నాం కాబట్టి second electron ఎలాగో minus of అవుతుంది. Okay. So means there is no quantum numbers are equal. ఇక్కడ 4 కి 4 quantum number difference ఉన్నాయి. Okay. So it is not compulsory that all quantum numbers are different. Sometimes maybe some quantum numbers are equal. So according to మన Paulis principle ఏంటంటే 4 set of quantum numbers equal ఉండవు. అంటే 4 set మొత్తం ఈక్వల్ ఉండదు కానీ దాంట్లో 1 ఈక్వల్ ఉండొచ్చు, 2, 3 or 3 వరకు ఈక్వల్ ఉండొచ్చు. 4 కి 4 వాల్యూస్ ఈక్వల్ గా ఉండవు. Okay. Now see other example. Okay, write down. Now we see the other example which shows this rule exactly. Magnesium 12. 1s2, 2s2, 2p6, okay, 3s2. So now it becomes what easy for comparison. Now there is two electrons are present in 3s. Okay. Now write the quantum numbers for this first electron and this second electron. The n value 3. For this also n value 3 because both are present in a third level, third shell. S లో ఉన్నాయి కాబట్టి L equals 0, L equals 0. L equals 0 కాబట్టి M equals 0, M is equals 0. The first electron if you take plus of, the second electron must be take minus of. So here this example exactly proves that Paulis principle is correct. See, even the two electrons present in the same box and the same orbital electron unna kuda n value same undi, L value same undi. Okay, n same, L value same, M value same, but L values are, S values are different. అంటే ఒక్క బాక్స్ ఇంతకంటే పాసిబిలిటీ ఉండదు మనకి. ఒకే బాక్స్లో ఉండడం కంటే క్లోజ్ పాసిబిలిటీ ఈజ్ నాట్ ప్రెజెంట్ ఫర్ టూ ఎలక్ట్రాన్స్. అంటే ఒకే బాక్స్లో ఉన్న టూ ఎలక్ట్రాన్స్ కూడా ఎన్ ఎల్ ఎం వాల్యూస్ మే బి ఈక్వల్ బట్ ది కంపల్సరీ డిఫర్ ఇన్ దర్ స్పిన్ క్వాంటమ్ నెంబర్. అంటే ఒక ఆటమ్స్ సంబంధించి ఏ టూ ఎలక్ట్రాన్స్కి ఫర్ ఎగ్జాంపుల్ వేరే దాంట్లో నీకు ప్లస్ ఆఫ్ ఉండొచ్చు, దీంట్లో ప్లస్ ఆఫ్ ఇంకో దాంట్లో ప్లస్ ఆఫ్తో కంపేర్ చేయొచ్చు, బట్ దాంట్లో అదర్ వాల్యూస్ విల్ బి డిఫరెంట్. అంటే మొత్తం మీద 4 క్వాంటమ్ నెంబర్స్ మాత్రం 100% ఈక్వల్ అయ్యే ఛాన్స్ లేదు. ఓకే, దట్ ఈస్ కాల్డ్ Paulis exclusion principle. Okay, so you can try some more examples. Okay, next is the Hund's rule. It is also known as Hund's rule of maximum multiplicity. So maximum multiplicity. So according to Hund's rule, it mainly tells about filling of degenerate orbitals. So what is mean by degenerate orbitals? So degenerate orbitals means, for example, if you take P, excuse me. So P తీసుకున్నామనుకోండి, there is a 3 boxes are there. Px, Py, Pz. So both 3 are having same dumbbell shaped. They are having same energy. They are having 100% same. 100% same energy. Just they are different in directions. In energy they are 100% equal. This type of orbitals are known as degenerate orbitals. Okay, means what are degenerate orbitals? Now we can write the orbitals having 100% equal energy. The orbitals having 100% equal energy are called degenerate orbitals. Okay. For p orbital example, for p orbital there is 3 degenerate orbitals are present. P orbital, you can say p subshell. It is called threefold. 3 unnayi kabatti it is known as threefold degenerated. For d subshell there is a 5 boxes are there, 5 orbitals are there which are having same energy. That is known as 5-fold degenerated. In the same way for F we know 1, 2, 3, 4, 5, 6, 7. There is 7-fold degenerated. So the Hund's rule tells about the filling of electrons in these degenerate orbitals. Okay. So now you are able to know the degenerate orbitals, which are having 100% equal energy, are known as degenerate orbitals. Now we see what is Hund's rule exactly. So Hund's rule ఎలా డిఫైన్ చేస్తామంటే in filling of degenerate orbitals, by electrons, at first all that orbitals filled with a single electron, then only pairing of electron takes place. So it is very important to learn rule. So in filling of degenerate orbitals means which are having same energy. So ఇలా ఉన్నాయి. For example, this is 3p అనుకుందాం, అంటే 3px, 3py, 3pz. So ఈ 3p లో ఎలక్ట్రాన్ ఫిలప్ అవ్వాలి. 3p లో ఫిలప్ అవ్వాలంటే ఫస్ట్ x లో ఫిలప్ అవ్వాలా, y లో ఫిలప్ అవ్వాలా, z లో ఫిలప్ అవ్వాలి. So that is information given by Hund's rule. By electrons at first all that orbitals filled with a single electron, there only pairing of electron takes place. For example, 3p లో only one electron choice అనుకో, first ఇలా fill up అవుతుంది 1, next second ఇలా fill up అవుతుంది, third ఇలా fill up అవుతుంది, next whatever fourth. Now after filling of all orbitals with a single electron, now pairing will start. Okay, so this is called a Hund's rule. Okay, so it can be written as, in other terms, that based on spin, in filling of degenerate orbitals by electrons, at first all that orbitals filled with the electrons with the parallel spin then only pairing will start. ఫస్ట్ అన్నిట్లో 1 1 ఫిల్ అప్ అవుతాయి కదా. సో అన్నిట్లో 1 1 ఫిల్ అప్ అవుతుంది అంటే ప్లస్ ఆఫ్ తర్వాత మళ్ళీ మైనస్ ఆఫ్ అలా ఫిల్ అవ్వాలి. సో బోత్ ఆర్ హ్యావింగ్ సేమ్ మీనింగ్. సో యూ నీడ్ టు రైట్ 2 డెఫినేషన్స్ సెపరేట్లీ. సో ఫస్ట్ లో ఇక్కడ దాకా సేమ్, with a single electron, then only pairing of electron takes place. First definition. Second definition, again continuously right from here. In filling of degenerate orbitals by electrons, at first all that orbital filled with electrons with parallel spin, then only pairing will start. Okay, now we see an example for it. What is the configuration of carbon? 1:2, 2:2. Okay, that is 2p2. So 2p2 means how we can write, distribute the electrons 1 2. Then Nitrogen 1s2, 2s2, 2p3. So how we distribute the 3? 1, 2, 3. Then what about oxygen? We write 1s2, 2s2, 2p4. Now filling takes place. Pairing is started. So pairing starts. So fluorine 9. 1s2, 2s2, 2p5. 3, 4, 5. So we are writing electron configuration. Already we know well about this electron configuration. So, but what is the background in this means? There is about we are following the Hund's rule. Okay. So these are the main rules for it.